Dear students, let us continue our discussion on neighbor reactions. So, we will be solving few questions based on the neighbor reactions from previous year papers of JEE and NEET. Okay? So, here we will be discussing about Hoffman bromide reaction. So, in the last session also, in the last live session also, I have covered what exactly Hoffman bromide degradation reaction right now. So now I will be showing you a few questions related to this particular reaction. See what happens. I just want to give you basic idea, then I will be going for the next question. Okay, see, so just I told you to remember like this. C double bond O NH2 group will be there, like amide will be there. So these upon treating with NaOH plus Br2 or any halogens like fluorine and chlorine, bromine, iodine. So it can be chlorine, bromine, iodine generally considered. Okay. So now what happens is just remove this part. Amide will be converted into amine like RNH2. So this is the basic thing I have told you to remember. Right now I have explained mechanism also and what is the intermediate involved. All things are discussed in the last live session. You can just check in the playlist. You will be getting that video. You can watch it and clear your concept very clearly in that. Okay. Now here I will be solving question regarding that. See what happens, you tell me. First reaction. See, this is JEE Mains 2021 paper. The question says here we have amide. They are treating this with KOBr. So what is this KOBr? So that is nothing but so this is nothing but what? So when KOH is treated with Br2, so we will be having KOBr, something like this. Okay, so this is taken here directly. So what is the major product formed? So what I told you, just remove this group C double bond O and write the remaining part as it is like this. C double bond O, I mean benzene ring here, Br here and nitrogen like NH2 group here. That's it. This will be your product in the first reaction. Okay, let me change the color. Yeah, and the next. So what about this? See, amide, same reagent, same substrate, treating with lithium aluminium hydride. See, we know lithium aluminium hydride is a strong reducing agent, reduces this amide group, this C double bond O group to CH2. So that we will be getting primary amine as a product here, like Br2, here CH2, NH2. So this will be the change. Amides converts into amines. Okay. So what is our AB in the options? So one is like this and other one is like this. So look at the options. See, we have A option as NH2 but no Br. So this is not the one. So next option here we have this one is our first option and there are other 4 options which includes here Br also. Okay, so that will be our answer, like this will be A and this will be our B. Hope this is clear. So how we are solving these neighbor reaction questions right now. Okay, so let us move forward with one more question here. See, for a practice purpose I am giving you one question, tell me what is the answer. Here NH2, treat this with NaOH plus Br2. Okay, heating. So what is the product formed here? What is this product A in this reaction? So tell me in the comment box based on your understanding. Okay, next let me move forward with one more reaction. So Beckmann rearrangement also we discussed. So what I told you, oximes like all oximes, ketoximes will be converted into respective N-alkyl amides. So reaction I have discussed and also given some examples in the last session, you can watch it. Okay, now we will be solving a question related to this Beckmann rearrangement. So here I am giving you one question, just tell me the answer. So here I have something like this. Okay, now here OH group like this I have. Now treat this with acid. So what is the product formed, tell me. So I just told you whatever the trans to this OH group migrate to this nitrogen. So that resulting amide is formed, N-alkyl amide is formed. So what is this? So carbon having one cyclopropyl ring, write it as it is. The trans group to this OH should be migrated onto the nitrogen. So migrated it is NH, and a benzene ring here, phenyl ring, okay, and on this you should put double bond O, amide we got. So from oxides we got amides, N-alkyl amides. This will be the Beckmann rearrangement. Next, for mechanism, you can watch the previous session, live session, just go through the Nemer reactions in the playlist or in the live sessions. So you can watch Nemer reactions 100 days challenge part 2. You will be looking into that video, it will be there. Yeah, so now here we have a question, very important this is. So this is benzylic rearrangement. So what happens here? See, we have two keto groups now, two carbonyl groups now. Now we are treating that with NaOH in the first case, and in the second case it is acidic reagent. What happens this NaOH? See, is there any acidic group? Tell me in this given reagent substrate. Is there any acidic group? No acidic group now. So now NaOH can act as a nucleophile, not as a base here, because if there is any acidic sensitive group like any acidic group, that will be react with this OH and forms an acid base reaction, neutralization takes place. But there is no acidic group, therefore OH minus act as a good nucleophile. So now identify the electrophilic centers here. See, carbonyl carbons are these two carbonyl carbons are the electrophilic centers right now. So now where this OH minus will attack, on this carbon or on this carbon, that is a big question here right now. So now identify which is more electron deficient. See, this carbon having pi electron, that will be dragging towards oxygen. Here also it is dragging towards oxygen. Both are having partial positive charges, but which is having more electron deficiency, more positive charge, that will be this carbon. Why? Because see, here we have an alkyl group, we know it is electron releasing group, that will donate the electrons into the ring, that will be given towards this carbon. Therefore the electron deficiency on this carbon is relatively less when I compare with this. So which is more electron deficient? This carbon is more electron deficient, because there is no group like this here, electron releasing group, that helps this carbon to have more electron density, but here completely electron deficient when I compare with this right now, more electron deficient carbon. So OH group will attacks here. This is the primary and important step for getting an exact product in the given options. So we got the reaction something like this, CH3 as it is, so C double bond O as it is. So this will be converts into, see what it is happening here, like this. So OH group is added over here, and this is becoming single bond O minus right now, like this. Hope it is clear up to here, right? The next, what's happening in the next step? See here, O minus is there now, again it gives back this negative charge into the ring. Since reaction is taking place in NaOH, like NaOH reagent, means already reaction contains OH minus concentration, highly concentrated OH minus is there. Right now this OH minus is a very bad leaving group, that will not goes out. Now what is the other thing we have? So this group, whatever alkyl or aryl group is there, that will be goes from here. So what we are going to get here, see, CH3 I am writing, and C here, C, this is shifted back side now, so OH. So here this migrated group will come from here to this position, because this is also electron deficient now, so this will be converts like this. So here we will be having O minus like this. Okay, so now followed by acid hydrolysis, it means just add H plus to this O minus, so that we get OH here, that's it. So this will be our final product, OH. So just check which option is having this kind of answer. See, pH is nothing but benzene, like phenyl ring only now. So see, in the first option you have COOH, pH, OH, and this like methyl benzene, right, methyl with phenyl ring. So this is what the first option says our correct answer right now. Hope it is clear right now. Yes, let me move forward with one or two more questions. See, I will be giving, see, I hope you got every step is clearly understood now. Now I will be giving a sample question for exercise purpose. So just try this question. writing here NO2 and here NaOH, the first step, and second step acid. So hope just follow whatever the steps I have mentioned here, follow that and tell me final answer. See here methyl we have, here NO2 we have. What is the nature of that groups? Identify that. It is live, those who are in the start box, it is live, just watch it. Okay, you can interact with me. So here methyl group is there, here nitro group is there. Now what is the nature of these two groups? This is releasing group, withdrawing group. So electron deficiency will be more on this carbon. So OH minus will attacks here. Right now, after that group migration, this ring alkyl group or allyl group migration takes place to this position. So tell me the respective product, and you can post your answer in the Telegram group. Our Telegram group, that the link of the Telegram group is there in the description. You can join there and you can post your answer. So I will be looking into it. Okay, so if there is any confusion, you feel free to ask me here. Okay, next. So here I have a question based on Hoffman bromamide degradation. See, very easy question. See again JEE main question here. Hoffman bromamide degradation of benzamide gives product A, which upon heating with chloroform and NaOH gives product B. The structures of A and B. So take the substrate they are saying is CONH2. Okay, after this treat these with Hoffman bromamide degradation, means treat this with NaOH plus Br2. Okay, this is what Hoffman bromamide reagent. Okay, so now what happens here? So just remove this C double bond O part and write the remaining part as it is CNH2. So we got aniline as our A. So this is our A. Aniline is a product here A. So this should be treated with what they are saying, with chloroform CHCl3 and NaOH. Right now, so chloroform with amines. See, amines, primary amines with chloroform undergoes carbyl amine reaction. What happens in carbyl amine reaction? See, these primary amines are there now, this NH2 group and this Cl. So that will be removed and gives us alkyl isocyanates or aryl isocyanate like NC. So like this, I can simply write it as like this. Okay, so this is a product formed here. So this is our B. So it will be having very bad foul smell. We are saying the primary amines are identified by carbyl amine test. What is this carbyl amines? Primary amines treated with chloroform in basic medium gives this kind of product, isocyanates as the products. Hope this is clear. So what is our A and B? A is our aniline and B is our isocyanate. Okay, so we have A here and B here. So this will be the perfect answer for this question, right? Hope it is clear. Yes, if this is really clear, just click on the like button and you can also express the way of explanation and all. If it is really clear, just write in the chat box. It is clear, sir, right? Yeah. So next, we will be giving you one more question. So just tell me, based on this, I will be giving a similar kind of question. See, I have something like this. NH2. Okay, so treat this with NaOH, Br2 NaOH. Okay, and you will get A. This A you react it with CHCl3 in basic medium. You will get B. So what is this A and B? You can write the names of the products in the comment box. Okay, next. Yeah. So here we have Claisen condensation. What is this Claisen condensation? Look at here. Esters condensation in the presence of a base to form beta keto esters. For example, here ethyl acetate is there. What is this acetate? CH3 CO COOH is, this is what? Acetic acid. Now if I say this like this, it should be acetate. Now they are saying it as ethyl acetate now. So it means, so you should have something like this. This ethyl group, ethyl acetate. ethyl group and acetate group. This is what the given example. Ethyl acetate is an example of ester. Okay, so this should be treated with a base. Okay, so I am taking here sodium ethoxide, EtO minus Na plus. This is a base here. Et means ethyl group, ethoxide ion here, sodium ethoxide. Okay, so this is taken here. So now what happens? This will abstract a base. I am saying now this is a base. So base abstract acidic proton. So where do we have acidic proton? See, during the reaction, I have to take this ethyl acetate as 2 moles, or let us say I am taking 2 molecules of this ethyl acetate. So one molecule I am treating it with this base. So base will abstract an acidic proton. Where do we have acidic proton? The alpha position to the carbonyl group is alpha carbon. So present, the hydrogen present on this alpha carbons are acidic hydrogen. So this will take a proton from here and results to form CH2 minus and C double bond O OET like this. Okay, so these out of 2 moles of ethyl acetate, I have only taken 1 mole. So now another mole will be there now. So that I am taking here CH2 C double bond O OET. Like this I can write now. OET. See now here negative charge is there. We know this carbonyl group containing species are electron deficient, or I can say electrophilic centers are there on this carbon. See, because this oxygen will drag the electrons, so creates partial positive charge. Okay, so to that, here we have a nucleophile. We have a nucleophile formed in the first step, that will be attacks at this electrophilic center carbon. So that we have CO minus, CH3 this side, OET this side, and CH2 CO OET like this. Okay, after this, what is the preceding step? You just estimate what happens. This O minus will be again given back because reaction is taking place in basic medium. So something has to be removed out here because O minus will not stay like that right now. So it will be given back. So ethoxide ion is coming out. So what is our final product formed? See, CH3, C double bond O, CH2, CO, OET. See, all to this ester carbon, this is alpha, this is beta. So we have beta position keto group. So beta keto ester, this is ester group, this is keto group. So we can say it is a beta keto ester formation is taking place. Now I will be showing you one question based on this. Previous year question I have. See, the major product formed in the following reaction. See, to be frank, this kind of questions are your rank deciding in the exam. So why I am saying rank deciding? Because most of the students are unable to identify where the proper exact reaction is taking place or what kind of reaction has to be taking in this given substrate. It is very difficult, and some of them are scared by looking at the structures, like this much big structures and all. So see, I have 2019 question. Just look at here. We have sodium ethoxide, and under heating condition we have this is okay. So this is a base here and abstract the acidic proton. So look at here, we have ester group here and keto group here and here. So now these protons are acidic, alpha hydrogens are acidic protons. So that will be removed from there. See, 1, 2, 3. If reaction is taking place between these two, we know that is a 3-membered ring which is highly strained ring. So reaction won't feasible there. So now what are the other possible? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. If the reaction is taking place at this keto group or this carbonyl group, yes, we are going to get a 6-membered ring. What is that 6-membered ring? First of all, use this base. When you use this base, from here one proton is removed out of this 2 and forms a negative charge here. Right now, a carbon ion formation taking place here like this. Okay, so this carbon ion is nucleophile now, attacks at this electrophilic center. Now which is best electrophilic center? This is the best electrophilic center because the resulting species formed is a 6-membered ring, that is highly stable when I compare with this 3-membered ring when it forms if we react here right now. So that's why it will react here to generate a 6-membered ring. Okay, so this is intramolecular, within the molecule reaction is taking place right now. So now what happens? We are going to get a 5-membered ring already there, a 6-membered ring is forming. So I am writing a 5-membered ring first. To that I am connecting a 6-membered ring. Just like this. Now start numbering here. So I am saying this 1, 2, 3, 4, 5, 6. Okay, so this is 5 I told you, this is 6, write that numbers, and this is 4, 3, 2 and 1. So on one carbon we have this ester group, C double bond O, OET, okay, and on the 6th carbon it is becoming single bond, so single bond O minus like this, okay. Next what I can make, O minus, okay. On 3rd carbon we have keto group, write that keto group here like this. So now what is the next step? See, this is what we got, but look at the option. Yes, we are almost near to the closer to the options. Most of the options are looking like this. Now what is the other step possible? See, here this O minus will be converted into what? OH group first. See, they have mentioned it as heating condition now. See, we have one more alpha hydrogen here, that is also acidic. So removal of this OH and H as a water takes place and resulting to give a product like this. Like this. So look at the options, where do we have this kind of option? See, like this, 5 member ring, 6 member ring, a double bond here, like this and like this. Everything is perfect, so your option C will be your perfect answer for this question. Hope it is clear. Now see, it might be looking very lengthy right now, but if you understand the concept, very easy questions you can do within the seconds only. By just looking, you can do with your eyes, no need of taking pen, paper and all. Okay, so but practice more. So practice this reaction twice and thrice like this. First you make clear with this basic reaction, and once again give a try for this. You will definitely get to solve this kind of questions easily in the exams. Okay, next, here I have one more question based on some few more neighbor reactions. So tell me here, first one is what? Amide is given treating with Br2 NaOH. So what happens with this Br2 NaOH? We know amides with Br2 NaOH, just now we have discussed bromamide reaction now. So this will be resulting to form, just remove this part, this will be your product. Okay, so what they are asking, how many of the transformations given below would result aromatic amines? So first one will results to form aromatic amine. So what about the next reaction, this B? So this is called as like potassium thalamide reaction. Here it is called as Gabriel thalamide reaction. This given substrate is potassium thalamide. What is the name of this reaction? Gabriel thalamide reaction. Okay, GPR you can remember, Gabriel thalamide reaction. Okay, so now what happens here? See, potassium is there now. We know potassium alkali metals are positive. Okay, so now nitrogen should have negative. Okay, and this is our aryl halides. See, if we have any alkyl halides like RCl, like RCH2Cl, something like this. Now this is a nucleophile. This chlorine goes out, generate positive charge on the carbon, so that this negative charge nitrogen will attacks here. So we can expect a reaction. But given reagent is what? Here the reagent given is aryl halides. Now aryl halides, in aryl halides no SN1 reaction or no SN2, no substitution reactions in aryl halide. Therefore the nucleophilic substitution will not takes place here, because chlorine lone pair electrons are in conjugation with the ring pi electrons. Therefore the reaction is not feasible. So this reaction not feasible for the further proceeding. Okay, next, what about option number C? See, reduction of this NO2 group with hydrogen and palladium in charcoal, that will be giving you aniline like NH2, reduced product. Nitro group converts into NH2 group. Okay, this is correct. Okay, next, this is also possible. A, C are possible, and you know we have this CO like acetanilide. So what happens upon it is upon treating with dilute sulfuric acid. It means water we have and acid we have. So this will be hydrolyze this and forms aniline in NH2 group, and along with that acetic acid is formed. So this is also giving primary like aromatic amines. So A, C, D is your answer for this question. Hope this is clear. Now look at this. Which are the following compounds can be prepared in good yield by Gabriel phthalimide synthesis? Just now I told you. So what we have to take one phthalimide here like this. Phthalimide means like this. So this is the phthalimide. Okay. So now if I treat this with base like KOH and all, any base KOH or NaOH, so what it will take, this acidic proton is removed by this base like an acid base reaction and forms salt right now. So that salt formed here is potassium phthalimide, like N minus K place. Potassium phthalimide is formed. So this potassium phthalimide is used for the preparation of amines. So now this will be treated with alkyl halides, like alkyl halides. For example, if I want to prepare like ethylamine, if I want to prepare ethylamine, I can use ethyl chloride. So now what happens, this chlorine will goes out, chlorine will be replaced by this nitrogen. Okay, we have product something like this. See, just remove this chlorine and add this next, this whatever the part we have. Like this. So followed by hydrolysis. If you do hydrolysis, so just break these bonds like this, and what you have, add hydrogens here, OH here. So you will get CH3, CH2, NH2. So we got ethylamine as a product. This is about the Gabriel phthalimide synthesis. This is useful for preparation of what? Primary amines. What I am saying, it is useful for preparation of primary amines only. So now in the given options, look at here, which compound will be obtained in the good yields. See, this is not amine, so this is not our expected product. Okay, and the next one, in order to prepare this product, we need to have benzene ring, phenyl ring with some halogens like this. But I told you aryl halides will not involve in the reaction because substitution reaction is not favorable here. Therefore, aniline cannot be prepared using this method. Okay, remove A also. Now I told you this is the method for preparation of primary amines, but option D, if you look at here, this is having secondary amide, like nitrogen is having this side methyl group and this side also ethyl group. So this is a secondary amine now. So secondary amines are also not prepared, only primary amine. See here, this can be prepared because I can take benzyl chloride like this. See, I am not taking aryl chloride, I am taking benzyl chloride. Now I can remove this and I can replace with this phthalimide, so like potassium phthalimide, I can get a product of this one like this. So option C will be your perfect answer. See, in the final product of this Gabriel phthalimide synthesis, you will get only nitrogen from this big ring. So even if you are seeing this much big ring, so what you will get out of this, you are going to get only this part. That is what, like nitrogen we are getting from the source of this phthalimide. That's it. Okay, hope it is clear, man. Ashutosh, it is clear now? Right. Let me go with few more questions. See, now I just wanted to give you one more question as a practice purpose. See, I have like this, I have something like this, and I am using some A substrate, and here I am giving KOH and heating condition. Now what is our A for preparation of this thing, CH3, CH2, CH2, NH2. I want to prepare this. Now tell me what is the suitable A, substrate A for preparation of this. Very easy now. See, I told you from this much big molecule, we are not going to take all this thing. We required only this part of this molecule. Right now, only NH, like N is required from here. So, but I want to prepare this complete thing. So, it means I want this ring, this much substrate, this much group I want from this A. So, our A can be what? Now, our A can be propyl. How many carbons? 1, 2, 3 now. So you should take this propyl halides. Propyl halides like propyl bromide, something like this for this reaction. So bromine is removed out, and for to that position this nitrogen as NH2 will be coming inside. Hope this is clear now, right? If it is clear, just click on the like button, right? Hope this is clear. So I will be asking you one more question. I wanted to prepare this one. I want to prepare this. So what is my A here? So just remove this remaining alkyl part is there now. So that you should attach to the halogen. That's it. Cyclopropyl chloride, cyclopentyl chloride or cyclopentyl bromide you should take for the preparation of this particular amine here. So what is the thing I have told you in Gabriel thalamide synthesis? It is only suitable for preparation of primary amines, and you cannot use this reaction if substitution is not taking place on the alkyl halides or aryl halides. For example, this reaction is not suitable for preparation of these things like vinyl chlorides are there now, something like this. So you cannot do this reaction using this, so that I cannot produce something like this. I cannot produce this kind of product because the chlorine present on this ethyl like this ethyl group, I can say ethylene group, I can say this is vinyl chlorides are not involved in nucleophilic substitution now. Therefore this kind of product is not obtained, or other than this like benzene, like aniline kind of products are also not prepared using this reaction. This is not suitable for production of this kind of products. Hope it is clear. Okay, limitations I have discussed, mechanism I have discussed, examples I have discussed, and PYQs also discussed regarding this Gabriel thalamide. Hope everything is clear. Now if you have any concerns or any doubts regarding this concepts that I have discussed, you can feel free to express in the chat box. I will address them. Okay, so thank you for watching. If you haven't subscribed the channel yet, just click on the subscribe button first, so that you can stay connected all the time and you won't going to miss any of our live sessions and live updates. Okay, so thank you.